All right, guys, I've got a good one for you today. This is testing the logic of a priori. Okay, we're going to use Python to do some a priori logic here. So a priori is an algorithm that's widely used for data mining and discovering association rules or patterns or matching, influencing types of things, particularly in market basket analysis. Okay, and it helps identify, like I mentioned, patterns, relationships, different types of correlations between items in a transaction data set. So a typical use case would be to understand purchase patterns and behaviors in retail or e-commerce. But there's many applications. We'll see in just a moment. An example, typical common example would be in a grocery store. A priori can help us identify combinations of items that are often bought together. Okay, so these are the correlations or the relationships, and the purpose is for retailers to use these insights to optimize product placement, promotions, and cross-selling or upselling strategies. Okay. It's also used for product recommendations, content-based recommendations, inventory management, cross-selling, upselling, things like this, fraud detection, discovery, hidden patterns in your data set, and customer segmentation, right? And there's other ways to do this too. Clustering is a common way. So this is just one more method to help us um, create sense from our data set and draw insights from the data that we're working with. Okay, and this is going to be a pretty quick video. So I think we set the foundation here. So I'm looking at a bunch of items. I think we have about 100 grocery store items here: pasta, pasta sauce, chips, so on and so forth, down to cream cheese, pancakes, and syrup. Okay, so we are going to start here. The number of transactions could be 100. Like I said, we're going to create a list here, and we're going to add items or append items to this list. Okay, so we're going through the number of transactions. We are randomly looking at these combinations of all these items in this list right here. And for anything less than zero point 0.2, it has a relationship of 0.2, 20%. We are going to append that to this transaction data list right here. This is the list. Okay, so we're going to go ahead and run this and then display the results. So Control Enter to run the cell in your Jupyter notebook, and we'll see what we get. Okay, it's done. Nice, pretty fast, very seamless. So we have support and then the item set. Okay, so this a priori right here is going to do the lift for us. Just one single line of code is going to help us out big time here to get the frequency of items and the overall item set. Okay, I think we end up with a couple thousand or so combinations. Okay, 2214 combinations of items in of grocery store items. Okay, so this contains all the sets of items that appear together in the transaction table that we just created. Let's data table. Okay, with frequency above the specified minimum threshold, we set the support level to 0.02, so 20%. This means the item set appears in 20% of transactions. Okay, this helps us identify which combinations of items occur frequently, such as peanut butter and jelly. Those will probably be bought together. Hamburger buns and burgers will be bought together. Hot dog buns and hot dogs will be bought together. Coffee and milk will typically be bought together. Right? So we're setting this threshold 0.02, 20%, and we want to see what these combinations of items are again, so we can create useful product placement, so we can understand the relationships of what's being bought together and what's not being bought together. If it's not being bought together, then we don't really care about that. Okay, so we set the association rules, and we have another line of code that helps us literally do the lift here. This is called lift. We are lifting by this and sorting in descending order. So ascending is equal to false. We're sorting in descending order by lift. Let me go ahead and run it. Control Enter to run the code. And here we see the lift. I'm looking at the head, primarily. The tail will show you the least lift right here, 1.56. So this is chicken and shampoo is going to be bought with aluminum foil, okay? Probably not. And rice and toilet paper will be bought with bananas, probably not, right? We're looking at the lift. So the higher the lift, the better. Coffee creamer and chocolates will be bought with paper towels and Ziploc bags, typically, right? Paper towels and Ziploc bags will be bought with coffee creamer and chocolates, and juice and coffee creamer will be bought with Ziploc bags and frozen pizza. Okay, so honestly, I didn't know that. I didn't know that coffee creamer and frozen pizza is a good combination, but according to the a priori algorithm here, that's how it works. Okay, so let's go down and just dissect this just a little bit more. And this is it. This is the result here. So these are the combinations that we're interested in, and also with product inventory, it helps us understand if coffee creamer and chocolates are bought together with paper towels and Ziploc bags. As we're selling more and more coffee creamer and chocolates, we can expect to sell more paper towels and Ziploc bags. So when we offer coffee, when we reorder our supplies of coffee creamer, right, and our supply chain guys gotta um, get that out the door and get that over to our grocery store, we should also be ordering paper towels and Ziploc bags because we can assume, based on the a priori methodology here, when these guys are bought together right here, these guys also will be bought together, right? So we have to reorder our supplies when we get enough sales over a certain threshold, right? So the antecedent is basically items on the left-hand side of the rule. If this is the if part, and then this is the then part. So if this happens, right? If this happens, this is the antecedent, then this will happen. Okay, this is the precedent. I'm sorry, this is a consequence. This is the antecedent. Candy and tomatoes are bought together, and chips and condition are bought together. So this is the if, and this is the then. Okay, that's how it works. In um, in support of this, we have the threshold of 20%, right? So we're looking for at least 20% relationship between these items to go ahead and make this kind of determination. Okay, so the lift is the strength of the rule relative to how often the consequences occur independently. Okay, so lift at greater than one suggests a positive association between these items. So all of these have some positive association, even at the tail end of the data frame here. But these have the stronger relationships, right? So this is 10, this is 10. So anything greater than one is going to have a relationship. This is 10 times as strong as a one. This is 7 times. This is down 625 times stronger. Okay, tomatoes and chips. This is the if, and then this is the then. Candy and conditioner. Okay, and then it helps you identify which items lead to other purchases. Okay, and a priori basically works by finding frequencies of combinations of item sets, groups of items that appear together, have significant transactions, and this is using a minimum support threshold. That's at 20% that I alluded to before. And just to wrap up here, we're generating association rules. These are relationships between item sets that have high confidence and high lift. Again, this column right here is the lift column. So anything in the head of the data frame sorted in descending order, these are going to be high combinations, high frequency items. If this happens, then this will happen. Okay, so that is how it works. And that's it. Pretty much it, guys. Just like I promised, nice and short, keeping it tight. END. I always end it with a little n, so you know this is the end, and maybe I forgot to put something down here. No, you know this is truly the end right here. Okay, so that's it. Thanks for your time today. Appreciate it, and enjoy the rest of your day. Hopefully you learned something new. I definitely learned something when I was putting together my notes and doing the research for this teaching lesson today. Okay, there you have it. Thank you, and enjoy the rest of your day. Bye.